Let's now continue building our game and actually implement the game logic itself. And with game logic, I basically mean implementing the way how the game works. So we need to implement what happens when the guess is correct, so when it's equal to the secret number. We also need to implement what happens when the guess is too low or when it's too high. So basically we have these three scenarios. And to start, we actually need to define that secret number. Otherwise, there's nothing which we can compare the guess to, right? Now, where do you think we should define that secret number? Should we do it inside of this button handler, or should we do it outside? Well, the answer is that we should do it outside, because we only want that secret number to be defined once. So only when we start the application. And so that's out here, outside of the handler function. If we define the secret number inside this handler function, then on each click, we would get a new secret number. And so then the game would make no sense at all, right? We just need one number, which we can then compare to each of the guesses here on each click. So let's define the number. So I'm just going to call it number here. And now we need a random number between 1 and 20. And this is actually pretty similar to the dice roll that we did earlier in the fundamentals section. So we use math.random. And so math is basically an object that JavaScript gives us. And on there, we have a lot of different methods. And random is one of them. And it gives us a number between 0 and 1. So let me show that to you. So whenever I run this, it will give me a new number. And it's always different from the one before. Now, if I want a number between 1 and 20, I will start by multiplying this by 20. And so now we have this decimal number here, basically ranging between 0 and 20. But all this decimal here is just noise. So let's remove that. And for that, we use math.trunc. And I'm doing all of this here in the console, so you can see how this is building up. Okay. And so now I have a number which goes from 0 to 19. Because the result of this here will never really include the number 20. It might only include like 19.999999. But now we're cutting off that decimal part. And so we are now left with a number between 0 and 19. And so to elevate it to between 1 and 20, all we have to do is to add 1 here. And with this, we make sure that the number is always between these two boundaries. So let's grab this now. So now that it works, and put it here. And with this, we have our secret number. Now in the real game, the number will obviously be hidden, so behind this question mark. But now, since we are still in development, let's actually display the number here so that we can then test our game logic as we develop it. So let's select that number. And I think, again, we already did it before, but let's do it here anyway again. Let's just, so the class name is number. And then remember, we use text content, and to set it, we simply use the equal sign. And now, what do we put here? Well, just the number that we just calculated. And now, as I save it, watch what happens. Here we now have our random number. And as I reload the page, you will see different random numbers appearing. And again, for you, of course, it will be different numbers. And you see here 20, which is actually the maximum. So this means that 20 is indeed included in our range here. Just to check if it's all right. So if we don't see any weird numbers, but it all looks okay to me. And so let's now move on and actually compare the secret number to the user's guess. So here we already have the condition, if there is no guess, then just print to the message element that there is no number. So let's again check that. And indeed, it works. But now, what if there actually is a guess? So let's say else if, and now we will actually check if the guess is the same as the secret number. And since I'm always saying secret number, let's actually change the variable name. So double click to select it, and then I can double click on all of the instances. So that's this one and this one. So that's a nice VS Code trick. And so now I have these 3 cursors. So let's delete all of that. Secret number. So the code works the same now, but the variable name makes a little bit more sense. So let's create a code block here. And now we need to specify what happens when the guess is correct. So again, when the guess is the same as the secret number. That's essentially what the guess being correct means, right? So what should happen then is that the correct number message should be displayed. So let's copy that and put that here. And for now, that's actually it. So I'll just give it a save now. And so let's actually test this. So 5, which of course is different. And then in the future, we will want a message here saying that the number is too high. So we're going to do that in a second. But now let's just put the correct number here. And indeed, we now get correct number. So that's exactly what we defined here in this else if block. All right, so I hope all of it makes sense. And now let's work on that scenario that I just mentioned, which is when the guess is greater than the number. So you see that here in this big if-else if statement, we are covering all the different scenarios that might happen here to this number. So the first one was that there is no number at all, right? Then we checked if it's equal to the secret number, and now we will check if it's greater. So if the guess is greater than the secret number. And then what should happen? Well, let's again select the message dot text content, and then let's say too high. So the guess is too high now. And again, adding an emoji here. So I want this graph here. Okay. And now also, since we are working on this, let's account for the last situation or the last scenario as well, which is that the guess is lower than the secret number. So guess below secret number. And with this, we covered all the scenarios. Let's just copy this one now. Too low. And now we're using the adder graph here. Give it a save and let's test it. So right now we know that it's a 3. So let's try 12. And so now we should see too high. And yes, it works. Now let's test 1, which is too low, and it works again. And now let's test 3, which is correct. And indeed it is. Great. So that's working already. Now let's move on to the next step, which is to work with the score here. So remember that each time that we guess a wrong number, our score should decrease. So let me show that here to you again. So let's say 5 and see how it starts at 20, just like in our code. But now as I check wrong, so it's too high, and now the score decreased to 19. So let me check another one. And so now you see that my number goes down each time that I do a wrong guess. And so let's implement that in our code here as well. So as you see here, we start with a score of 20. And now in these two scenarios, where the guess is wrong, so here where it's above and here where it's below, we want to decrease that score by 1, right? Because again, each time that there is a wrong guess, the score should decrease by 1. So how should we do that? And I can think of two ways of doing that. The first way is to read the score from here, then decrease it by 1, and then print it here again. So that would be the first way of doing it, but there is a better way. And the better way is to actually create a variable for the score in the code and then update that variable, so basically to decrease that variable, and then display the value of that variable here in this score label. And by doing that, we have our data also in the code and not just on the DOM. And so that's always a very good thing to do. So let me do that now, and then I will explain it a little bit better. So I'm going to do that right here after the secret number. So const score, and as you already know, we start with 20. And so that's our initial score, so the value that we set to this variable. And actually this should be a let, because we will then decrease that value, remember? And so it cannot be a const, because a constant is immutable. Okay, and now here, let's go back to the wrong guess scenario, or scenarios, because it's this one and this one. And then all we do is to decrease the score. So score equal score minus 1. And maybe you already know, or hopefully you do, that this is the same as writing score minus minus. All right. So we decreased the score, and then all we have to do is to display that score here in this element. So once again, we already did that, so no need to repeat. So it's this one here. So we select the element with the class of score, and then as the text content, we give the score. All right, and that's it. Now we just need the same code also in the other wrong scenario, so where the guess is below the secret number. So I'm just copying this code and putting it here. Give it a save, and before testing it, let me again explain what we just did here. So as I said, we could have also stored this score basically in the DOM. And to do that, we would always just read this value from here, so right from the DOM, then we could decrease that value and then write it back here to the DOM. But then we would not have that value in our code. So essentially, our application would have no way of knowing that score at all points. And so it's always good to keep a variable which actually holds the data in our code and not just rely on the DOM to hold our data. All right. And this variable here can also be called a state variable, because this score is part of the so-called application state, which is basically all the data that is relevant to the application. And we could say that this 17, so the secret number, is also part of the state of our application. All right. And so we want all the data always to be available somewhere in our code and not just in the DOM. Okay. So always keep that in mind. And so that is why we implemented the solution like this. So whenever there's a wrong guess, we just take the score that we already have in our code, then we decrease it by 1, and then we display that new score right here. So let's reload. Let's say 17, and watch what happens to our score now. And indeed, it decreased to 19, and our number is too high. And when I click again now, you see it decreasing even more. Now let's try with a lower number. So too low, and our score decreased again. And actually, let's keep going. So let's keep clicking here and watch what happens. So I'm clicking over and over on the same button here, and our score keeps going down, and eventually we reach 0. And at this point, we should basically lose the game, right? But as you see here, nothing of course happens. And we can keep clicking here and go until infinity, and our program will of course not care, because our program obviously has no idea of losing or of winning the game, right? It is completely on us to write all that logic. So basically what this means is that all of this checking here, so doing all this here, should only happen whenever the score is still above 0. And then when the score is actually 0, then we should get some kind of message here saying that we lost the game. So let's quickly do that here inside of this scenario. So basically we need another if statement here inside this already else if block. And that's of course not a problem at all. We can perfectly have one if inside of the other. So what I was just saying is that this here, all of this, should basically only happen while the score is still above 0. So let's do that. So if score is above 0, only then do all of this. All right, and now else, so basically if it is 0, then we want to display another message. So we want to say, you lost the game with some losing emoji. So I'm going to use this one here. So that's an explosion, I believe. So let's test that now. And we only implemented this for when the guess is above the secret number. So let's now use 12. It's too high. And now let's keep going to test what happens. So we are approaching it now. And now we lost the game. But actually I could click twice as my score was already 0. So try this for yourself. I will just reload here and again put a number that is above. So now the score is 1, and as I click, we should get the message, you lost the game. So let's try. And it didn't happen yet. And it did not happen because the score was indeed still greater than 0 here, right? So we need to change that to greater than 1, okay? So again, a larger number. Now I get 1, and if I click, now you lost the game. And all we need to do is to then update the score to 0 here. So let's just copy this. Write 0. And then before we test it, we can actually copy the same code to this other scenario. Now, as you can see, we are creating a lot of duplicate code, and we will fix that by the end of this project. But for now, let's just keep working on this. And the only thing that really changes here is this message. So you see that here is some potential to eliminate duplicate code. But again, we will take care later of that. For now, let's just make it work. Okay, and with this, I think we're actually finished. Let's just test it. So 5 is too low. So let's keep going down. And you lost the game. Great. Now let's test a larger number. And I keep clicking here. And now we lost the game too. Great. So our game logic is already working, and actually the game itself is also kind of working already. There's just two things that are missing here, which is the high score and this play again button. But before implementing that functionality, in the next video, we're going to talk a little bit about CSS and how we can manipulate styles using JavaScript.